Hi everyone, welcome to Ms. Sawagid's math class. We will continue talking about volume. Volume is the measurement of how much space a three-dimensional object takes up, which means how much can you fill an object with. Three-dimensional objects are called solids or solid shapes. Examples of solid shapes are the cylinder, the cone, and the sphere. We already talked about the volume of a cylinder, the volume of a cone. Today, we will be talking about the volume of a sphere. Let's review the volume of a cylinder. To find the volume of a cylinder, it's V equals BH, where B is the area of the base and H is the height. Because a cylinder has a base in the shape of a circle, then the area of a circle is pi r squared. Multiply that by the height, gives you the volume. Now let's review the cone's volume. To find the volume of a cone, it is 1/3 the volume of a cylinder with the same base, same height, and I will review this with you soon. So V equals, B is the area of the base, which is pi r squared because it's a circle, times the height, but I need 1/3 of that, and that would be the cone's volume. I can rewrite this equation different way, just to make it easy for me to find what the volume is using this equation. For today's lesson, how can I find the volume of a sphere using a cylinder with the same height, same radius, which means the base of the cylinder has the same circle in the middle of the sphere. We're able to find the equation for the volume of a cone using a cylinder with the same height, same base. Let's review that. One cone equals 1/3 of a cylinder because it filled only 1/3 of the cylinder. But one cylinder equals 3 cones because one cylinder will fill 3 cones. Now let's find the volume of a sphere using a cylinder with the same height, same radius. And we'll discuss that soon. One full sphere filled 2/3 of a cylinder, which means the volume of a sphere is 2/3 the volume of a cylinder, and the volume of a cylinder is equal to 1.5 the volume of a sphere. Before we write the equation to find the volume of a sphere from the volume of a cylinder, let's talk about characteristics of a sphere. The biggest example, everybody knows that the earth is in the shape of a sphere. And if I take half of that, it's called a hemisphere, and a sphere has 2 hemispheres. Let's take one of those hemispheres, tilt it just a little so you can see the circle in the middle of a sphere. The line going from one corner to the end, crossing the center, is called a diameter. But half of that is called the radius. What's special about a sphere, that if you take the top of the hemisphere to the center of that circle is also the radius. Keep that in mind. So if I go to the whole sphere, from the top to the center, that's a radius, and from the center to the bottom is also a radius, and from one side to the center, that's a radius, and from the center to the other side, that's also a radius. Did you notice something? There isn't a height. The height equal the diameter. And I can rewrite it with the radius h equal 2 times the radius. So the height of a sphere, h equal 2r. So the height of a sphere is the diameter, and the diameter equal to 2 times the radius. Now let's write the sphere's volume using the cylinder's volume. This is the cylinder's volume, but I need 2/3 of that. So write 2/3 pi r squared times the height. That's the sphere's volume. But remember, the height is the diameter, which equals to 2 times the radius. So I'm going to replace the height with 2r. Now simplify that equation. 2 times 2 is 4/3 times pi Multiply r squared times r gives you r cubed. So this is the volume of a sphere, which is 4/3 pi r cubed. I can rewrite this equation, 4 pi r cubed, all divided by 3, just to make it easier for me to find the volume of a sphere. Here's the first example for today's lesson. Find the volume of a sphere. Round your answer to the nearest tenth. First of all, write the equation. 4 pi r cubed, all divided by 3. Now let's see what they gave us. They gave us the radius, which is 4 centimeter, and the volume is what I'm trying to find. Substitute the numbers we know in the equation. V equals 4 times pi, which is 3.14, and the radius is 4, but make sure you cube it, all divided by 3. Now let's simplify the equation by multiplying all the numbers on the numerator. First of all, though, you have to cube 4. 4 times 4 times 4 is 64. So you end up with 4 times 3.14 times 64 divided by 3. Now multiply all the numbers on the numerator, you get 803.84 divided by 3. Simplifying by dividing by 3 again, you get 268.08. Since you're rounding to the nearest 10th place, 0 is in the 10th place. Now, does that 0 stays the same or goes up 1? It all depends on the 100th place, which is the 8. Since 8 is more than 5, then the 10th place goes up 1. So the volume of that sphere is 268.1 centimeter cubed. Now here's another example. Find the radius of the sphere. Round your answer to the nearest 10th place. We're trying to find the radius, but they gave us the volume of 36 pi cubic meter. Watch how they kept the pi with the volume. So when I write the equation, 4 pi r cubed all divided by 3, I will not replace pi with 3.14. I will keep it the same. Watch how this works. Substitute what you know. Volume is 36 pi equals, bring the 4, bring the pi, bring the r cubed, all divided by 3 the way it is because there's nothing to replace. Now I need to isolate the radius to find what the radius is, get rid of all the numbers on the same side as the radius. Since a 3 is free by itself on the denominator, the inverse operation of division would be multiplication. So multiply both sides by 3. Now 3 times 36 pi is 108 pi equals, watch how the 3 divided by 3, that's cross division, they cancel each other. You end up with 4 pi r cubed. Again, I need r by itself, so this time I need to get rid of the 4 and the pi. Since I'm multiplying those, I will divide both sides by 4 pi. 108 divided by 4 is 27, and pi divided by pi is 1. They cancel each other, that's why I kept it. I did not replace it with 3.14. Same thing with the other side. 4 divided by 4 is 1, and pi divided by pi is 1. 1 times r cubed is r cubed. Now I don't want r cubed, I want r, which is the radius. So the inverse operation of cubing a number is the cube root. So cube root each side. The cube root of 27 equals 3. Cubing and cube root, they cancel each other. You bring the r down, so the radius equals 3 meters. Here's the last example for today's lesson. This is a silo farmers use to store grain. It's in the shape of a hemisphere and a cylinder. Let's talk about this example. The top of a silo is a hemisphere with a diameter of 24 feet and a height of 52 feet. What is the volume of the silo? Round your answer to the nearest 1,000. Let's talk about the dimensions they gave us first. The diameter is 24 feet. But I know to find the volume, I need the radius. The radius is half of the diameter, which is 12 feet. The height of the silo, all of it, from the top to the bottom, is 52 feet. But I know that the hemisphere, from the top to the center of the circle of the hemisphere, is also the radius, which is also 12 feet, because it's the same as the radius of the bottom of the silo. Now I need the height of the cylinder by itself. Since the whole silo is 52 feet and the hemisphere is 12 feet, then the height of the cylinder is 40 feet because you subtracted 52 minus 12 is 40 feet. Now let's write the dimension to find the volume of a cylinder added to the volume of the hemisphere. The dimensions for the cylinder, where the radius we found at 12 feet and the height of the cylinder by itself is 40 feet. To find the volume of a sphere, all I need is the radius, which is 12 feet. Now let's start with finding the volume of the hemisphere. Write the equation 4 times pi r cubed divided by 3. Substitute what you know, which is the pi 3.14, and the r, or the radius, is 12, but you need to cube it. So first of all, cube 12. 12 times 12 times 12 is 1,728. Now multiply all the numbers on the numerator. 4 times 3.14 times 1,728 is 21,703.68. Divide all that by 3, gives you 7,234.56. That is a sphere, and I don't want the sphere. I want half of that, which is hemisphere, because the top of the silo is in the shape of a hemisphere. So to find the volume of a hemisphere, you divide the volume of a sphere by 2, gets you 3,617.28 cubic feet. Now let's find the volume of the cylinder. Pi r squared times the height, substitute all the numbers that you know. And I know 3.14 per pi, radius is 12 but squared, and the height is 40. Now square the radius, which is 12 squared, is 144. Bring everything else down. Now multiply 3.14 times 144 times 40, gives you 18,086.4 cubic feet. That's the volume of the cylinder. This is the volume of the hemisphere. Add them up, will give you 21,703.68, but I need to round this to the nearest thousand, and the thousand place would be the 1, but to decide, does that 1 goes up or stays the same, I look at the number right after that, which is the 7. Since it's more than 5, then the 1 goes up 1, you end up with 22,000 cubic feet. And that is the volume of the whole silo. In today's lesson, we were able to find the volume of a sphere from a cylinder. And we were able to write the volume of a sphere as 4/3 pi r cubed, or rewrite it as 4 times pi r cubed, all divided by 3. We know that there isn't a height for the sphere. What's special about it, that this would be the diameter, or 2 times the radius is the same as the height of a sphere. We were able to find the missing dimension, just like the radius of a sphere, or finding the volume of a composite solid, just like this side. Thank you for subscribing, liking, and commenting on my videos. You guys have a great day. See you next time.